welcome everybody. You won't have to look at my face for a long time. I'm going to start sharing my screen really quickly here as well. I've been working in and around network technologies and various functions for a very long time, longer than I care to admit. We tried to build a unified messaging system on the AOL backbone back in the early 90s, which was ahead of its time in the 90s. Today is still ahead of its time. I was an engineer before I went to law school. And today I'm neither. I'm a VC in what people call the blockchain space. We internally don't really call it that. We have a more nuanced taxonomy, and I'm gonna explain why that is. So let me share my screen. So unfortunately, like I like to say, reality doesn't have an advertising budget, which means that everything that you find online about the topics of crypto and blockchain is some form of motivated reasoning or simply just advertising copy. And that's also unfortunately true for things that academia teaches and for things that government individuals are commenting on. But it's more adequately summarized by my good friend John Oliver, who said cryptocurrencies combine everything no one understands about technology with everything no one understands about money. And that's funny because it's true. So when people talk about crypto, this is usually what they have in mind. They think about cryptocurrencies. They think about Bitcoin. They might think about Ethereum or some meme coins. But crypto is really just short for cryptography. So it's really about much more important topics. And I usually like to start out for those people that don't interact with cryptography on a daily basis to just remind everybody how it works in principle. And I have kind of a kindergarten version for you here. So if I'm Bob and I want to communicate safely with Alice here, then I can use cryptography to put a message into a box, put my lock on that box, and send it to Alex. Well, Alice now has a box with my lock. That's not very helpful. She doesn't have the key. So she'll put her own lock on that box. Now it's the box is locked twice, sends it back to Bob, and Bob takes off his locks and then sends it back to Alice. Now Alice has a box with her own key to it. And that is the kindergarten version of cryptography, or here specifically public key cryptography. So that allows us to do peer-to-peer interactions. And I must have seen well over 1,000 presentations that try to explain Bitcoin. Most of them are wrong still today. And I encourage everybody to carefully read the Bitcoin white paper. And even if you're not that technical, just read the abstract or even just read the title. So the Bitcoin design paper, it's really design paper, it's not a white paper. A lot of people will explain it as it's solved for the Byzantines' general problem. That is incorrect. The Byzantines' general problem was actually solved by Leslie Lamport back in 1982. And it also didn't invent blockchain technology. Actually, blockchain technology is not mentioned, and blockchain is not mentioned in that paper. The paper references in its second footnote a prior paper called Design of a Secure Timestamping Service, which was shared at a symposium in the Benelux in 1999. And that explains blockchain technology, which is different from blockchain. And I'm going to talk about that later. Whenever someone says something to the extent that they're using blockchain technology, what they're actually doing is they're using a particular type of encryption. And oftentimes people that are using it don't understand the difference between the two, which is kind of a little bit like not understanding the difference between utilizing internet technology versus building the internet. So the title is really important. And over the past 7 years, we interviewed well over 1,000, well over 2,000 teams. And I must have asked the question 1,000 times, what did the Bitcoin white paper solve and what does a blockchain do? What is the function of a blockchain? And surprisingly, very, very, very rarely do we get an actual correct answer. And there is a correct answer to be had. That's the important part to understand. So the design paper is called peer-to-peer cash, a peer-to-peer cash system. What's great about cash? Well, cash is great because I can give it to you. I don't have it anymore. It settles a transaction with finality. You didn't need to see my passport, and otherwise there were no intermediaries involved. So it makes for a very good substitute in the case where we don't have anything to barter. And as a little side note, cash, as manufactured by the United States, is indeed its most lucrative and valuable export product. More than $1 trillion of these Federal Reserve notes, which they technically are actually internationally being used for conducting commerce. And even though they're legally IOUs, in practical terms, they actually don't come back. It's just a useful technology that people like to use. And over time, a dozen countries actually simply adopted it as their unit of account and gave up on issuing their own. So that's why today, the vast majority of global GDP is measured in US dollars, and the US dollar is the world's language of value. And that's the primary function, and that's very important to understand. And I'm going to harp on this a lot, the difference between what is the function and what is the use case, which is a logical fallacy that's being committed not only by engineers on a daily basis, a conflation more correctly, it's a formal logical fallacy, but also by regulators and people at the Federal Reserve, and it leads to very unfortunate outcomes. There are 180 languages of value, so 180 different currencies, but really only the US dollar, and then as a distant second here, the euro has any relevance in international commerce at all. But then when we look at the actual transactions, so as in what is being transacted with, we'll see that cash, so peer-to-peer cash, or there specifically the US dollar in this particular case, is rarely used today in commercial transactions. About 3% of value that's being transacted. It's actually a little more in transaction count because there's a lot of small transactions usually that are being transferred using $5 notes or something like that. And as a result of overprinting, we see this particular graph that the Fed in St. Louis actually published and then eventually discontinued. So what this means in rough terms is any dollar note that's been printed on average gets exchanged for goods or services 4 times in a given year. So that's the velocity, the times this particular currency, this particular instrument, this particular technology is used for actual commerce 4 times a year. So what does that mean? What does that mean in context? Well, the context is cash is really the only thing that our central bank is issuing. Then is a much larger bucket here of commercial bank currency that's legally and technically different. And then the central bank also makes the distinction between non-bank currency. It's not really technically correct. We'll get into that a little bit, but I'm using it because that's what the Federal Reserve recently published. So we're using their guidelines for 1 second here. As mentioned, there's about $2.3 trillion of physical cash out there, which is about 6% of all US dollar denominated currency in the world at the moment. And it's great because, as I mentioned, it's a peer-to-peer bearer instrument. I can use it anonymously. I cannot be censored. There's usually no fees involved, which is very different from the currency that commercial banks issue. And there's an important term here, issuing it, as in many discussions in public news are being had around the issuance of quote unquote money, a term that we're going to get into, by the Federal Reserve, while commercial bank money is typically not discussed, even though these are actually the main culprit of debasement. And they're also the main culprit when it comes down to fees and things like infringement of your Fourth Amendment rights, charitably called KYC, Know Your Customer, or AML procedures. The third bucket is really also commercial bank currencies, but it's the commercial bank currencies that you right now hold with non-bank institutions. Think PayPal, Zelle, Zenefits, these type of what I call faux fintech companies. So this is by and large how transactions work today. We got Bob. Bob wants to send Alice some currency, so he instructs his bank, sends his bank a message, and then his bank sends a message to Alice's bank, and his bank adjusts his ledger, and then Alice's bank adjusts her ledger, and that might take a day, that might take 4 hours, or that might take weeks, or it might never happen. But this is how most commercial transactions happen today. So now we're finally getting to crypto and blockchain adoption. And what's the difference here? So I already explained peer-to-peer transactions in a cryptographic system. And so to this day, I get still on a daily basis emails that say, yo, crypto adoption, blockchain adoption. And that's where the statement ends. And whenever you see these statements and you're trying to make a decision whether or not it's worthwhile engaging with, you want to ask a couple of questions. You want to ask, who is adopting it? For what are they adopting it? And why? And then most importantly, if you're an investor, even if you're investing your time, when? So let's start with the granddaddy. Let's start with Bitcoin. Is there Bitcoin or Bitcoin adoption as money? Well, you always want to differentiate between the uppercase B and the lowercase b. What's the difference? The uppercase B is the name of the network. And unfortunately, Satoshi was a little lazy and also named the mining reward Bitcoin. And it's very important to keep in mind, this is the mining reward. There is no currency per se, and we'll get into that. So is it being adopted as money? Is it peer-to-peer cash? Well, there's a very unfortunate definition of money, which goes back to a little pamphlet written by William Jevons in 1875. That's William. And he defined money as a medium of exchange, a unit of account, and a store of value. This is a logical fallacy. It was wrong when Jevons wrote it. It's wrong when the Federal Reserve uses it. And it's wrong when developers are trying to implement this particular definition as a useful taxonomy in their technology. Because observably, we saw this is the medium of exchange. By default, the medium of exchange is bytes. And by the way, on the left side, you're seeing $1 billion worth of Bitcoin. On the right side, you're seeing $1. So how about unit of account? Well, I assume wherever you are, you either see your Bitcoin holdings in dollars, or you might see it in euros, you might see it in yen. What does that tell you? Well, the unit of account, by and large, if your default medium of exchange is actually bytes, is simply an interface function for an engineer. So what's the confusion here? Well, the confusion here is a logical fallacy called a conflation. I'm conflating currency and money. So what's the difference? Money is a legal concept. Currencies are technology, and you are probably more interested in the technology itself. And just real quick, to make this very simple in terms of explaining what's the confusion here, the function of a hammer is always the same. It centralizes centrifugal force. And then your typical use case is probably to put a nail in the wall. If you change the use case and bash someone's head in, you didn't change the function one bit. And so that's the difference between currency and money. One is a function and one is a particular use case. If you and I agree that within our personal transaction, the US dollar in its paper form is money, then it's money. If I hand it to you and you use it to make origami or kindle your fire, then that's the function that you're deploying afterwards. So it's a particular use case that I don't actually have knowledge whether or not you accept it as money, or you decided you really like this piece of paper for some other reason, or your particular digital technology that you're developing actually will immediately transfer my shitcoin, and every fiat is a shitcoin, into something that I consider a store of value, and maybe you instantly convert it into Satoshis, into Bitcoin. So this is what we're looking at today, and this is just simple data that you can readily aggregate yourself. The primary use case of Bitcoin today is that of speculation. BTC daily turnover is about 7.5% of its entire market cap, which means that within 2 weeks, the entire market cap moves back and forth. And a lot of people treat it as a store of value, so they hold on to it for years. And you can see that and measure that as well. And then actually made this triangle a little larger here than it actually is in terms of transactions and payments. So there's very few people today that use it for actual transactions and payments. And they are specifically, obviously, very rarely on mainnet, since the transaction cost would be very high. And there's some activity and some development on Bitcoin Lightning, so on the second layer solutions, which is more interesting. So then people are trying to classify these tokens and coins. And yes, these are different things. A coin is the native reward mechanism of the blockchain of layer 1, and a token is basically an API function or standard. So some of these classifications are semi-useful, as in there might be commodities, there might be network tokens that I need to run a dApp, a decentralized application. Stable coins is kind of a large bucket in terms of what these things actually are. Most of these are pegs. So obviously something that I peg to something that is indeed disappearing over time cannot really be considered stable by per se. And then we got things like governance tokens. But by and large, you really have to look at the individual transaction, and we will do that. But I'm going to pick out one use case here. And again, it's interesting that a lot of claims are online always made about use cases without simply going to a block explorer or an aggregator and just observing the actual use cases. So what's the actual use case of stablecoins today? Well, you can just go to CoinMarketCap or one of the other aggregators, and you see what Tether is used for. Well, Tether is used for speculation against other assets, mostly Bitcoin, Ethereum, XRP, surprisingly. And that's its use case. And it's a good use case because within that use case, the velocity of this particular currency, this particular token, is almost 100% of its market cap on an average day. And remember what I said earlier, the velocity of the US dollar of the printed version is 4 times a year. So in comparison to something like a stablecoin within this particular narrow use case, it is 2 orders of magnitude greater already for this particular little token. But what I'm trying to explain to you is more important, meaning when you look at Block Explorer, and here's just a simple, boring transaction that I grabbed from a Block Explorer before I made this presentation earlier, you will see you get some basic data here, and will tell you what is the block that's being included, what are the transaction fees, and so forth. So very little data really, unless obviously you start attaching other information to that, which by default you shouldn't. And if you're a developer, you definitely should avoid that. And actually, whenever you don't, what we call internally here, you invalidate the herd immunity of your particular application, which means if you're creating and using a blockchain-based solution for anything else but its primary function, you're probably using it wrong. It's like using the hammer to bash your head in. What do you mean by that? There's a singular function of a blockchain, which is to change control over a set of bytes from one address and one controller to another address. And obviously, I don't even know, by looking at a transaction here as for comparison Etherscan, I don't know who is the controller of that other address, or if these are the same people, or what is the legal nature? So do I know whether or not someone is using Ether as a currency? I do not. And as I mentioned, I was a lawyer for a short period of time, and there is very, very simple frameworks for commercial activity that you can as well learn in the next 30 seconds, and you'll never forget it. And then you don't have to actually label anything as a transaction, because you don't know if things are a transaction. That is kind of a laden term that developers unfortunately use, because this is really a state change. So blockchains are state machines. They're not recording machines. That's not the purpose. So in legal terms, there's really in principle only 4 ways that you exchange value. You either exchange it for a product or service. We often call that a payment. I'm missing a bracket. You exchange it for shared interest. That would be Gary Gensler's equity. And Gary, for some reason, thinks that he can read everybody's mind and call everything an equity, which is utter nonsense, obviously. He has no idea, without inquiring both participants and both controllers of an address, whether or not this particular exchange happened for shared interest. There's no way of knowing that unless both participants declare so on every transaction. Then I might give you something, I want it back. We call that a loan. And then I might also simply donate something to another address. And again, I have no way of knowing without the parties declaring such. This is how value is being distributed across the space of cryptocurrencies, quote unquote. Terrible term, by the way. Most of these are obviously not currencies. And again, anything can be currency. If you find yourself in an inmate in a prison, you'll find out that currencies might be cigarette butts. It's very much situational. But the larger point here is all of these values are measured in the billions, with Bitcoin obviously taking the largest portion here, 42%, and Ether taking another 19%. But really what it doesn't do is integrate with real world economic activity. So when you look at real world economic activity today, and that's what we do, is we identify the largest markets. So because the largest markets often have the largest friction. If you exchange real estate today, the velocity of real estate is very, very low. Why? Because it takes a long time, it takes a lot of fees. On average in the United States, that might be 7% of that value of that house that's being actually accumulated by people in the middle. And until we have digitally native things like digitally native house titles and land titles, they will continue to do so. But similar friction exists for all the other large markets, bonds, oil futures, equities. And one of the largest frictions is still in fiat currency. Global GDP in 2021 stood at 96.5 trillion, while the legacy financial services system raked in 22.5 trillion. So napkin math will tell you that this legacy technology, which I would consider technology debt, so database solutions, oftentimes dating back to the 60s, exert about a 23% penalty on the real economy. And by real economy, and that's not a term that I came up with, but the International Monetary Fund, is the exchange of goods and services. So financial services only exist in the context of the real economy, because otherwise they don't really have to exist. So at the example of fiat and the ability of the legacy financial system to manipulate that, 4% of US household income and your income goes directly to commercial banks. This is data published by the Federal Reserve. On average, for everything that you're buying or for every service that you're paying for, there's an additional cost of 6%. It's the merchant account fee plus whatever the merchant adds for any type of settlement risk, for any kind of chargeback. And the legacy financial services system debases the currency by on average 7% year over year for decades at this point in time. So now I want to zoom out to something that is both easy and important to understand, I think. So human beings are about 350,000 years old. And for the longest part, we have been using our wetware, our brains, to remember that we gave something to someone and wanted something back later. That's how commercial transactions were facilitated, with that little ledger in our head. And then about 3500 BC before Christ, we developed the earliest forms of writing, clay tables. And then only 100 years after Christ, we invented paper. But now we have a little more modern technologies, and those are fairly recent. In the 60s, we invented database solutions. And over 40 years, we spent time and money on onboarding paper into databases and digitizing these entries. And you see the companies that made it big during those years. And then for 20 years, we started connecting these databases to cloud infrastructure to facilitate data transfer. And now what people call Web3, and a very unfortunate term, and we'll get into that. Now we're actually freeing up these bytes from that legacy infrastructure, from cloud infrastructure, from database solutions. So I'll make a couple of comparisons next to drive these points home to see what's the friction here. So if I have a full fintech company, so actually fintech is a term that was invented by a marketing agency to actually cover up window dressing solutions to the legacy financial system, because if you're using PayPal, you're still engaging with a bunch of commercial banks ultimately. But you can see that PayPal does that with 26,000 employees, whereas a network like Ethereum at any given point in time has 64 full-time developers. Of course, there's lots of open source developers donating code. I won't disregard that. And obviously, this is a sort of that apples to oranges comparison, but it's just to showcase that you can facilitate transfer of value with less people, with less friction, and being less extractive. And as you can see, Ethereum's market cap already exceeds that of PayPal over a short period of time. And you'll see similar data if you look at legacy finance, even those that call themselves fintech, like Lending Club, and you compare it to decentralized systems like Aave. So you see that a decentralized system was able to already generate more loans in a much shorter period of time by, again, having a larger market cap already with way fewer people, way less effort, way less friction. And maybe also to the point that I actually didn't make a separate slide about, which is this constant claim that blockchain-based solutions are energy ineffective and waste carbon and so forth. This propaganda doesn't need any more research. It just needs one number. And that number is 3.5 cents, which is the amount that miners paid last year to energy creators. How come? Well, 3.5 cents is probably much lower than what you're paying for your energy. And it's actually much lower than almost any company is paying out there. Why? Because Bitcoin is the only global energy demand network, which means Bitcoin and Bitcoin mining, or otherwise mining in general for any type of token or coin, is simply able to go wherever the energy is the cheapest. And it's the cheapest where there's no other buyer bidding for it. Energy is typically very localized. Bitcoin is not. So what that means is that Bitcoin, outside of the fact that most of Bitcoin is today already being mined using renewable energy, it is using extra energy. It's not competing for energy. It's not another polluter. That is just utter nonsense. Anybody who is claiming that has an agenda or is otherwise just simply misinformed. Anybody participating in the call is probably familiar with Coinbase. Coinbase obviously doesn't use a blockchain per se. It's more of the same. It's a bank. They're running databases, and that obviously was also the problem of FTX. It's a database company. It's not a blockchain company. And now we're seeing that decentralized exchanges already have the same volume, much fewer people, much less carbon. Whenever you see people, you think carbon. JP Morgan Chase has 250,000 people working there. Think about that. They all turn on their computer in the morning, probably drive their car to work. And they probably spend more in energy pollution in a given month than Bitcoin spends an entire year. Moving on to the topic of digital collectibles. We are part of the ecosystem, so we had a little bit to do with actually forking ERC 1155, so the more advanced NFT standard, into the Ethereum blockchain. And unfortunately, now today, NFTs are associated with digital collectibles, even though that's kind of a really like niche use case and really not all that interesting as far as we are concerned. We already taught in 2017 at our local meetups here, what is the relevance of NFTs, of non-fungible tokens, for things like supply chain? So I'm just going to walk you to very, very simple kindergarten example of how supply chains work today and how they might work in the future. And actually, we're seeing the adoption of that already. So I might have an idea for a product or service. I might decide I want to plant grapes. I get a loan, start planting grapes, and eventually they ripen. I put them in bottles and I record how many bottles I have, and then start juggling them in a supply chain. I'm putting them into a database and shipping them around, and then the wholesaler puts them into their database, and then eventually it ends up at a store and you pick it up from that store. And you walk away, and then eventually this particular bottle ends up in the trash. What's my point? The point here is whenever you see those databases, there's a record being transferred from the one data silo to another. In the example of supply chain specifically, 47%, so nearly half of all the records that are being transferred in this type of manner are simply false. And that's why everybody had this scenario at one point in time where you're at a store and the clerk there tells you, yes, this product should be on the shelf, but it's not. My database tells me that, but it's just simply not. So how could a supply chain look using NFT principles? Well, same starting point. I think of a product or service. I plant some grapes, but then I start recording these on a blockchain-based solution. In this particular case, I record it on Ethereum, and then I associate, let's say, a QR code. And we did this examples in 2017. You'll find that on YouTube, and actually gave away those bottles with these QR codes. And interesting enough, those NFTs are worth a few $100s today. Most people lost them. And I might hand over this particular NFT to another supply chain-based blockchain. And from there, I'll hand it over to IOTA or another supply chain. And maybe then I'll hand it over at the POS system to something like a Stella or something else. And then you pick it up. And when you pick up the bottle, you also get that NFT. You also get this digital clone that refers to the ownership of that bottle and all the metadata, hopefully, that was accrued during its journey in the supply chain. So both in meat space and physical space, as well as in digital space. So this is about data integrity more than anything else, and data security. So where are we today with adoption? Well, adoption is very, very early, even if what we did here is include everybody who had some brush with quote unquote cryptocurrencies, meaning they bought some Bitcoin or Ether on a centralized exchange. Is included in here, which is really less than 2% of the global internet population, which, as a frame of reference, I was selling dial-up services in the late 90s, and we managed to aggregate about 300,000 people using our dial-up service, which was a big feed back then, but it was that low because we had to send out affiliates that were installing dial-up modems in everybody's computer. So that's kind of where we are today. We're kind of in 1997, maybe 1998, in terms of the adoption of these solutions and people kind of installing dial-up modems, i.e. MetaMask or something else, in order to interact with these solutions. But then what's important to understand, what are the forcing functions? What will force people to adopt these technologies? And a lot of times, again, people talk about cryptocurrencies and or slapping labels on things that are DLTs, they are decentralized ledger technology, which is the opposite of a blockchain, by the way. The Bitcoin white paper doesn't mention a ledger, and DLTs are essentially shared databases. But what are the actual forcing functions that we can observe? If you have an iPhone and you pull it up and you actually open the digitally native wallet that Apple offers you, so just swipe down and search for wallet, you will see that there is now 4 states that will import your digital driver's license if you're in Arizona, and 4 other states. And Louisiana built their own for whatever reason. Point there being, this is a cryptographic primitive. It's a digitally native credential using a particular ISO standard and exchanging data in a particular way that I'm going to show you. But then other forcing functions that we can already tell today is central banks starting to issue digital native primitives. Private stablecoin projects, to some extent, are finding adoption for narrow use cases on platforms at the moment, including by some of our portfolio companies. Then we're already seeing certain governments asking specifically that particular government functions have to be on blockchain-based solutions. Saudi Arabia has declared that by 2024, all government functions have to be blockchain-based. And then the most important one is really something that I touched on briefly, which is that of cybersecurity, data integrity, data safety. And I'm going to break this out a little bit. But before that, I know we're getting short on time. Before that, I'm showing you that particular example, if you haven't already done this on your phone, where now you can actually store your digital native credentials on your phone, stored on the enclave on the iPhone, and exchanges this with the TSA, with the Transportation Security Administration, and local law enforcement in a very particular way. And what I mean by that is essentially, to simplify this massively, passing on a green checkmark. Because law enforcement and or TSA is not interested in your first and last name or where you live or how old you are usually. They're interested in receiving this green checkmark, and this is how that works. Point there being is, if, when, where these solutions are being adopted, you, if you're a developer, you, if you're running a project and a startup in the space, need to be aware of these existing standards. Here's ISO 18013 that's being used to transact and verify, identify, certify this different legal levels, certain transactions, if, when, where that's needed, i.e. KYC in the past, and that will be invalidated. And we could talk about that more in the Q&A. So the other forcing function, though, is cybercrime. Cybercrime as an industry is larger from a GDP perspective than all but 2 countries, meaning the United States and China specifically. So cybercrime exceeded $6 trillion in 2021, is on trajectory to reach 10 trillion by 2025. And the reason for that is being because we are playing a cybersecurity theater with data today. Because anybody who knows anything about databases knows that perimeter security, network security, endpoint security, and so forth are all ultimately useless if, when, where that guy in the middle is actually being breached, which is the case 8 out of 10 times, meaning it's a social engineering attack. And this particular individual has access to just way too many data, because legacy solutions, so database solutions, are secured by a permissions layer. And the difference here is, and again, in the interest of time, I have to very much curtail this, but the difference here is that with cryptographic solutions, the authentication, verification, certification, any type of access rights are built into the data itself rather than creating a layer. So there's a lot of unhelpful terms in our space. A lot of times people throw metaphors around. One of my pet peeves, even though I had one of the groups at the Decentralized Identity Foundation, is the term digital identity. It's a metaphor. There's no such thing per se, meaning identity requires consciousness. What we're really talking about is something else. What we're talking about is how we're addressing current web topology. So what do I mean by that? So again, we're almost out of time, so I have to really simplify this. So currently, the web operates under what I would call a push paradigm. Everything is pushed in front of you, meaning you're actually never on the web. If you're using Google, you're not on the World Wide Web. You're a non-player character in a game called Google. Google is selling social engineering as a service to the highest bidder. And that's true for all the other platforms. Whenever you hear the word platform, think this is not the World Wide Web. You're just another walled garden. It's a few steps removed from what we had in the mid-late 90s with AOL. It's not the World Wide Web. So in the context of these particular data silos, there's billions of databases that provide data sources that pertain to you. And then there's thousands of profiles built. And to differentiate you here, to understand this and get your hands around this, is a persona is the data that you can control online about yourself. So the fields, let's say on LinkedIn, Facebook, that you have control over, then the data that's being appended to that by the platform you're engaging with is called a profile. It's being created to profile you. So an average profiler will have 4,000 data points on you. And by the way, it takes 4 data points to identify you with almost 100% perfection. And you probably know that. So a useful metaphor that I personally like, and I like you to embrace, is that of a digital vending machine. I stole that from Nick Szabo, who might be Satoshi. And the point that being is Bitcoin created kind of this first version of a digital vending machine, meaning I put in a quarter, I turn the dial, and I can see the gum come out. And Ethereum then started to build more universal vending machines where I can place anything else in there and that can represent value in the real world, even though it's very nascent today in terms of actually representing real world economic activity. And I have some slides in the addendum that we can use to exemplify that. But I'm going to summarize that with this slide, and then we're going to move to FAQs. So really, from where we are sitting, we haven't built the World Wide Web yet. As I said, Web 1, Web 2, Web 3 suggests this kind of linear development, which is very misguiding because it's really a reversal of the current topology. And as you can see here pretty easily, blockchains are also not protocols. A lot of developers keep calling them protocols. That's false. The reason why that's false is because content matters. As in, if I tell you I saw a panther in the parking lot here, then your visual is probably a car. If I told you I saw a jaguar at the zoo, your visual is probably an animal. And the difference here is blockchains exist in the context of actual protocols. So they're using actual protocols, and that's a very important differentiation to make. But then ultimately, what we're doing right now is really developing the World Wide Web for the first time, because we don't have, at least not in any relevant way, decentralized compute, decentralized addresses, decentralized bandwidth, and so forth. We're building these right now for the first time so that you don't have to jump from one platform to another and are subservient to social engineering as a service. And that's what we need to fix for everybody, for freedom in the world, and for what I call recreating reality consensus. I've been writing about these topics for a very long time. I've started writing about decentralized software solutions 15 years ago. I'm working on a few books. At the moment, I also teach a class at Harvard. And if you want to expand on that, there's a fintech program that Harvard offers for a teacher class, and also design the curriculum for them. I've published on Forbes a couple of times a year, little summaries, and then more geekier stuff on Hacker Noon.